Hello guys, we're going to do vector applications today. And the velocity of a moving object is a vector because velocity has both magnitude and direction. The magnitude of velocity is speed. Okay, when we're doing any type of navigation problems, just make sure that you are using the directional angle when you're putting your vector into component form. All right, and recall to find the magnitude of a vector, once it's in component form, it is just the square root of x squared plus y squared, and the direction of the angle is the inverse tangent of y over x. So let's just take a look at this aircraft on a bearing of 65 degrees. So whenever it just says bearing, that means that we are coming from the north. This is 65 degrees. Okay, so when we're putting it in component form, however, all right, we're going to use the speed, which is 500 miles per hour. It's also our magnitude. But this angle in here is the angle we have to use. That's our directional angle, and that is 25 degrees. Okay, so that came from 90 minus 65, which is 25 degrees. Okay, so the component form of this vector, I'm not going to work out the math in the calculator, but it would just be the magnitude times cosine of 25 degrees, and the magnitude times the sine of 25 degrees. Okay, and that's all there is to it. So let's look at another one. Now, this plane is on a bearing of 335, so from the north, 335 would bring us all the way up in here. Okay, and it's traveling at 530 miles per hour, so that's the magnitude. But we need to use the directional angle. So the directional angle here I'm going to get my color, starts at 0 and goes to the spot. Okay, so that directional angle, well, if it was 335, so 360 minus 335, okay, that is just 25 degrees. So this little bit in here is 25 degrees. So if I add 90 to 25 degrees, I get 115. So the directional angle from 0 for this vector is 115 degrees. So the components are right down below here. This is 500 times cosine of 15, and our vertical direction is 530 times the sine of 115. And if we plug this in our calculator, make note here, it's negative 223.987, which makes sense because I'm in quadrant 2, and the horizontal direction in quadrant 2, or the x direction, is negative. And I get 480.34 for my vertical direction, which is positive in quadrant 2. So make sure that that makes sense. Our directional angle makes sense with our component form of our vector. So let's do an example with some wind and an airplane, and how we combine the two of them. So if I have an airplane flying west, 450 miles per hour. It's going west, so we're going to just start right here, boom, going in the west direction. Okay, but I have a headwind, and not a headwind, not directly at us. It's coming from the northwest. So if it's coming from the northwest, okay, this is 45 degrees right here. And if this was straight down, this would also be 45 degrees, but just make note of that. So, when you're figuring it out, we will have to find the directional angle that's going to come into play. But so for the first one, let's just look at we got to add these two together to get our resultant vector. So we need to figure out what the components are of a resultant vector when we have an airplane traveling at 450 miles per hour and a wind coming at us from the northwest at 60 miles per hour. Okay, so the plane's directional angle, we're just going straight west, so this is 180 degrees. And that's important to go 180 degrees because that'll bring us in the right quadrant. So it's negative 450 times cosine of 180 and 450 times the sine of 180, and that represents the plane. Okay, the wind. Now, when you're figuring out the directional angle of the wind here, you have to bring it back. We're not going to be able to figure out what our angle is unless we just go back to the origin, and now we can take a look. So if I go around here to 270, and I told you with a northwest wind that will give us a 45-degree angle, so that is going to be 315. So our directional angle for the wind components is 315. So this would be 60. It's a 60 mile per hour wind, so that times the cosine of 315 and 60 times the sine of 315. So once you figure out those in your calculator and add them together, okay, this is our resultant vector. And it makes sense. We're in quadrant 3, and they're both negative. Negative 407.57 in the x direction and negative 42.43 in the y direction, or the vertical direction. So we want to figure out now what our ground speed is, and we're going to figure out the bearing as well. So you just take the components of that vector, which were this, negative 407.57 and negative 42.43. Find the magnitude. So our ground speed is 409.77 miles per hour. And our bearing, we are going to figure out by using the tangent. Okay, so that gives us this little angle though, so we got to be careful. That there was our resultant vector. That inverse tangent of our component vector there, the y over x, this is 5.94. So if we're asked for the bearing, which this one did, so from the north, you would add, okay, actually you would subtract if you went 270 minus 5.94, it's 264.06 is the bearing. Now there's also some problems on this worksheet where you would say, okay, it's 5.9 degrees south of west. Okay. All right. So let's take a look at this vector problem in the worksheet. So if you need to go get it, stop right here and get your blue worksheet. And I just want to get you started with the first problem. So we have two vectors, and all they're asking us to do is find the component of vector r plus vector s. Okay, now in these, I'm going to do one graphically, and then I'll just put one in component form. So if we look at 60 degrees, okay, this isn't saying bearing. This is just saying at the directional angle 60 degrees. So this is 60 degrees, and our magnitude is 16. Okay, so I'm just going to drop down my triangle here. And if I'm figuring out the component form of this vector, okay, remember this part is the magnitude times the cosine of 60 degrees, and the vertical direction is the magnitude times the sine of 60 degrees. Okay, so the components of that vector after we do the math, so this is 13.85, and this one is 8. Okay, so cosine of 60 is 1/2. So our vector looks like this. It's just 8, 13.85. 5. So that's our vector R. Our vector S, okay, we're going to do the same way, but I'm just going to put it in vector form right away. So we have 35 sine of 100. What am I doing? Not sine, cosine of 100. And 35 times the sine of 100. So after we put that in our calculator, we get negative 6.07, and this one is 34.46. Okay, so if we want to find the components of a resulting vector, adding these two together, we would get 1.92 and 48.32. Okay, now we can use those components to find our magnitude and also to find our direction. Okay, so the magnitude is just going to be the square root of 1.92 squared plus 48.32 squared. And if you take the square root of those two added together, you get 48.362. Okay, and now to find the direction, we use our inverse tangent. You just take the component form here and divide the y over x. So it's 48.32 divided by 1.92. Okay, and now when you're doing this one, you got to be careful. Just make sure you're using it as kind of a reference angle. So depending where the vector is at, you wanna, this one's asking you to just find the direction so you can describe it in your own way. So north of east, east of south, or whatever you're gonna do. So if I find this angle, it's 87.72 degrees north of east. That's how we're going to describe it. And there's more than one way to describe your direction. Okay, which makes sense because we're in quadrant 1, north of east. All right, so work on your worksheets and do the best you can, partner up, and have a great day.